For the last problem in chapter 3, we have another constant acceleration equation type problem where we know the height that a object drops, which is 24 meters, and the horizontal distance it travels, which is 18 meters, and we're asked to find the initial speed at which this stone was thrown horizontally and the speed at the end when it falls. So for part A, we can say that V initial x equals V final x, which is delta x over delta t, or this is x final over t if we take the initial position to be x initial here. This is x final if we take y initial to be on the top, and y final will be down there. And the time it takes is for the object to fall the distance from y initial to y final, or to travel from x initial to x final. We know that y final equals y initial plus v initial y times this t plus 1/2 a sub y t squared. And if we take y initial to be 0, and since the stone is thrown horizontally, its initial y component of velocity is going to be 0, so we know that y final equals negative 1/2 g t squared. So we substituted a y for minus g in this case. And then t from this case is going to be the square root of minus 2 y final over g, which we know. We know what this is. We know these values, so we can substitute those in and get minus 2 times y final is 24 meters below y initial, so that's a minus, and then g is 9.8 meters per second squared. If we do this, we find out that it's 2.21 seconds. But now we can say that x v final in the x direction is the 18 meters over 2.21 seconds, which is 8.14 meters per second. And since there's no acceleration in the x direction, this would also mean that v initial x is this 8.14 meters per second. For part B, we're asked to find the speed just before it hits the ground, so we need to find what v final y is. So we can say v final y equals v initial y plus a sub y t, which is the same as saying, since v initial y is 0, this is minus g times t, or minus 9.8 meters per second squared times 2.21 seconds. And I don't want to do this calculation just now because we're going to use it in a square root in a little bit, and I don't want to keep rounding out numbers. So we can say now that the final velocity before it hits the ground is going to be the square root of v final x squared plus v final y squared. So this equals square root of this 8.14 meters per second quantity squared plus this negative 9.8 meters per second squared times 2.21 seconds, the whole thing squared, the whole thing under the square root. And now I limit the amount of rounding errors that I can get, and I get a final velocity of about 23.16